All right, folks, here's a quick video on how to determine which compounds would be able to dissolve in water or soluble versus which ones won't be able to dissolve in water, insoluble, sometimes forming a precipitate. So when we look a little closer at some of these, if you notice, all of the compounds that are in here are anions, right, or minuses. And what we then do is we take a look at the positives that we put with them to see if they are an exception to the rule. So for example, if we take a look at this first one, nitrates, right? It says all nitrates are soluble, which means that any cation that we put with a nitrate, silver nitrate, lead nitrate, even sodium nitrate, we would be able to dissolve this in water. So there's no exceptions to the rule. That's why we use nitrates quite a bit in this class, because we need to get these cations, specifically silver or lead or mercury, in solution. Nitrates are the perfect ones to use. But there are some exceptions to the rule here. And if we take a look at the first one, that is an exception to the rule on this, an acetate. So for example, it says, and they give you the two formulas for acetate. It's the same number of C's, H's, and O's. But it says all acetates will be soluble or will dissolve in water, except if it's a silver acetate. That means if silver and acetate ever bump into each other because we mix two solutions, say like a silver nitrate with something like a sodium acetate, and the sodium is going to be a spectator ion, and the nitrate will be a spectator ion, but the silver, when it bumps into the nitrate, to the acetate, it will form a precipitate and usually sink to the bottom. So therefore, it is an exception to the rule of being soluble. So therefore, this thing will be insoluble. And there's some other exceptions to the rule. For example, silver chloride is an exception to the soluble rule. Therefore, it will be insoluble. Mercury will be insoluble when it's with a chloride or when it bumps into a chloride, and so will lead. And if you notice, these three are very often returning in terms of the exceptions to the rule, because they are a heavy metal that has a very strong attraction to things like, in this case, chlorides, in this case, bromides, in this case, iodides. But then you also get the exception to the rule where it's a 2+ cation, such as barium, such as calcium, such as strontium, that come up a lot too, that are exceptions to the rule. And you notice how sulfates in this case, there are a few more exceptions to the rule in terms of that form insoluble or precipitates, or we would never be able to pull these apart in water or dissolve them. So some have no exceptions to the rule, right? Like these two, one exception to the rule, and then multiple exceptions to the rule. I think the hardest one to really figure out or really wrap your head around are the ones that are insoluble. Why? Because there's a couple of other, there we go. So insoluble. There's, most of these are insoluble or are going to form precipitates. In this case, you have your carbonates, something called a chromate, a hydroxide, phosphates, sulfites, which we really haven't talked about too much, and then our sulfides, IDE ending here. But in reading these, it's a little tricky, so let's take a look at the first one. It says all carbonates are insoluble, which means that they will form precipitates unless they're with some elements in the 1A column of the periodic table. So when we take a look at our 1A column here, our 1A column ends up being all the elements right here, the 1A column right in here. All right, so if we put any of these with, in this case, carbonates, they will dissolve in water. Any other carbonates are insoluble, are going to form a solid. So if it's a lithium, if it's a sodium, if it's a potassium, rubidium, cesium, francium, those last two you don't really see too often. With a carbonate, they will dissolve in water, but anything else that's a carbonate will become a precipitate or sometimes you could just say are insoluble in water. So there's a couple of other ones on here that again show us the 1A elements, the 1A elements, the 1A elements. So a lot of the 1A elements are exceptions to the rule for things that are insoluble or that form precipitates. I think that may be the hardest thing to really wrap your head around. So hopefully this video using this solubility chart helps. Let me know if you have any questions.